All right, class, this is the last video on section 6.2, integration by substitution. We're picking up the discussion at example 3 on page 80 of your note packet. So here we're going to find the antiderivative of e to the 3x plus e to the minus 4x with respect to x. Now we have a sum of two terms here. So we know we can anti-differentiate this function term by term. And so this is equal to the antiderivative of e to the 3x with respect to x plus the antiderivative of e to the minus 4x with respect to x. So we're going to have to use the substitution method twice, right? Once on this first integral and once on this second integral. So on the first integral, right, I'm let u equal the exponent 3x. Then the derivative of u with respect to x is equal to 3. You multiply both sides by dx, and you get du is equal to 3 dx. Now we have the dx, but we don't have the 3. So we divide both sides by 3, and we get 1/3 du is equal to dx. So substituting into this first integral, replace the 3x with u and the dx with 1/3 du, and we have the antiderivative of e to the u times 1/3 du. Well, the 1/3, right, is a multiplicative constant. It can be brought out from the integral, and we're left with 1/3 times the antiderivative of e to the u with respect to u. Now let's jump back up here to the second integral. Now you have to use a different letter of the alphabet so you don't mix things up. So I'm using v instead of u in the substitution method. And so I set v equal to the exponent minus 4x. Then the derivative of v with respect to x is equal to minus 4. Multiply both sides by dx, I get dv is equal to minus 4 dx. Now I have the dx up here. I don't have the minus 4, so I divide both sides by minus 4, and I have minus 1/4 dv is equal to dx. So substituting into this second integral, I replace the minus 4x with v, and I replace the dx with minus 1/4 dv. The minus 1/4 is a multiplicative constant. It can come out from the integral sign, and I have minus 1/4 times the antiderivative of e to the v with respect to v. So now let's find these two antiderivatives. Well, the antiderivative e to the u is just e to the u. So we have 1/3 times e to the u. The antiderivative e to the v with respect to v is just e to the v. So we have minus 1/4 times e to the v. And now that we're done anti-differentiating, we add the arbitrary constant c. Last step is replace u with what it's equal to and replace v with what it's equal to. Well, u is equal to 3x, so replace u with 3x. V is equal to minus 4x, so we replace v with minus 4x. And now this is our antiderivative to our original function. The antiderivative of e to the 3x plus e to the minus 4x with respect to x is equal to 1/3 times e to the 3x minus 1/4 times e to the minus 4x plus c. This is the final answer right here. All right, in example 4, you got to find the antiderivative of 2x cubed over the square root of x to the 4th minus 1 with respect to x. Well, we can let u equal x to the 4th minus 1 under the radical in the denominator. And if we do that, the derivative of u with respect to x is equal to 4x cubed. Derivative minus 1, you know, is 0. And then we multiply both sides by dx. We get du is equal to 4x cubed dx. Well, we have 2x cubed dx, not 4x cubed dx. So if we divide both sides of this equation by 2, right, we have 1/2 du on the left is equal to 2x cubed dx on the right. Right, 4 divided by 2 is 2, and dividing by 2 on the left is the same as multiplying by 1/2. So this 2x cubed dx up here is equal to 1/2 du. So substituting into our integral, right? Before we do that, we got to split up this quotient. I'm sorry, right? This quotient can be written as a product of two quotients, 1 over the square root of x to the 4th minus 1 times 2x cubed over 1. And 2x cubed over 1 just simplifies to 2x cubed. So now we substitute, right? Replace x to the 4th minus 1 with u. So we have 1 over the square root of u. And replace the 2x cubed dx with 1/2 du. So we have the antiderivative of 1 over the square root of u times 1/2 du. The 1/2 is a multiplicative constant. It can come up from the integral sign. And so we have 1/2 times the antiderivative of 1 over u to the 1/2 du. Remember, square root of u is the same as u to the 1/2. Now, 1 over u to the 1/2 is the same as u to the minus 1/2, right? Remember, the minus sign in the exponent means reciprocal. So u to the minus 1/2 is the same as 1 over u to the plus 1/2. So this is equal to 1/2 times the antiderivative of u to the minus 1/2 with respect to u. Well, the antiderivative u to the minus 1/2 respect to u, you add 1 to the exponent, and we get minus 1/2 plus 1 is 1/2. And then when you divide by 1/2, that's the same as multiplying by 2. So antiderivative u to the minus 1/2 is equal to 2 times u to the 1/2. And we're multiplying that by 1/2 out from the integral. So 1/2 times 2 is equal to 1, right? 1/2 times 2 is equal to 1. And we're left with u to the 1/2 plus c. Well, u to the 1/2 is the same as square root of u. So that u to the 1/2 plus c is equal to square root of u plus c. And now we replace u with what it's equal to. It's equal to x to the 4th minus 1. And so square root of u plus c is equal to square root of x to the 4th minus 1 plus c. And this is our final answer. The antiderivative of this integral up here, right? The antiderivative of this function, up here is equal to the square root of x to the 4th minus 1 plus c. This guy right here.